A dynamic load test, DLT, is a common method used to evaluate the capacity of deep foundations, such as piles, by applying dynamic forces, typically using a hammer or drop weight, and measuring the pile's response. The results can be used to estimate the pile's bearing capacity, integrity, and behavior under load. Here's the general procedure for a dynamic load test. 1. Preparation. Site preparation. Ensure the pile is driven or constructed to the required depth and ready for testing. Selection of hammer/drop weight. Choose a suitable hammer or drop weight based on the pile size and design load. The energy of the hammer should be sufficient to mobilize the desired pile capacity. Instrumentation. Attach sensors, strain gauges, and accelerometers to the pile near the head to measure the strain and acceleration when the pile is struck by the hammer. These measurements help calculate force and velocity at the pile head. 2. Equipment setup. Dynamic testing system. The sensors are connected to a data acquisition system that records the dynamic response, force, and velocity of the pile to each hammer blow. Hammer or drop weight setup. The hammer or weight should be positioned above the pile head, with guides to ensure a vertical drop or strike. 3. Initial calibration and alignment. Perform a calibration check of the sensors and data acquisition system. Ensure that the hammer or drop weight is properly aligned with the pile head to avoid any lateral forces that could skew results. 4. Testing procedure. Apply dynamic loads. Drop the hammer or apply the load in several blows, starting with lighter blows to prevent excessive damage to the pile. Gradually increase the energy of the blows. The number of blows is typically in the range of 10 to 15, depending on the required data and the response of the pile. Data acquisition. Record the strain and acceleration signals for each blow, which will be used to compute force and velocity. This data is used to estimate the dynamic pile capacity and evaluate its performance. Monitor pile movement. Check the pile for any noticeable movement or deformation between blows. 5. Data analysis, CAPWAP analysis. Force and velocity calculations. The recorded strain and acceleration data are used to calculate the force and velocity at the pile head. These values are then used to estimate pile displacement and the energy transferred to the pile. CAPWAP, Case Pile Wave Analysis Program. The recorded data is processed using the CAPWAP software to simulate the wave propagation along the pile and determine the pile's load-bearing capacity. Evaluate results. The dynamic load test results are compared with the design load to ensure the pile meets the required capacity. The test also helps identify potential defects in the pile or issues with pile-soil interaction. 6. Reporting. Analysis of results. Prepare a report summarizing the pile capacity, pile displacement, and energy transferred during the test. This includes both raw data and processed results from the CAPWAP analysis. Comparison with static load test. In some cases, the dynamic load test results are compared to static load tests to ensure accuracy. The dynamic load test typically provides faster results than static load tests, but may require verification. Safety considerations. Pile head protection. Ensure proper cushioning or protective measures for the pile head to prevent damage from repeated hammer blows. Personnel safety. Keep all personnel clear of the hammer or drop weight area during the test to avoid injury. Advantages of dynamic load testing. Faster than static load tests. Provides real-time results and immediate feedback on pile capacity. Cost-effective for large-scale projects. Can be used to test multiple piles in a short period. Dynamic load testing, especially when combined with CAPWAP analysis, is a reliable method for determining pile capacity and integrity, offering rapid, actionable data for engineers during foundation construction.